Welcome to my KCSE revision channel, Marita James. Kindly subscribe, click the notification bell, you get notified once I upload a new video. Today we are looking at laboratory preparation of ammonia. In laboratory preparation of ammonia, you need to understand the main reagent for the preparation of ammonia gas. Why is the reaction in the flask is in a slanting position? So you need to understand why is it in a slanting position. Then of course you also need to understand that we must have a suitable drying agent for ammonia gas, and once the gas has been dried, it must have been collected by the upward delivery because it is less denser than air. So ammonia is prepared in the laboratory by heating a mixture of ammonium salt and an alkali. So we are talking of a mixture of ammonium salt and an alkali. Ammonium salt, you can talk of ammonium chloride here. An alkali, you can talk of a slanked lime, which is a calcium hydroxide. Now, when you are talking of an alkali here, ammonia is more volatile phase and it is displaced by less volatile phase. For example, it can be displaced by sodium hydroxide, it can be displaced by sodium hydroxide, it can be displaced by potassium hydroxide, or it can be displaced by calcium hydroxide. So the sodium hydroxide, potassium hydroxide, and the calcium hydroxide are less volatile phase. Ammonia now, which is the a more volatile phase, can be displaced by this phase. Now, the main reagent for the preparation of ammonia is a dry ammonium chloride and calcium hydroxide. So here you have a mixture of dry ammonium chloride, a mixture of dry ammonium chloride and calcium hydroxide. Remember, it is very, very important to note that the reagent must be dry. The reagent must be dry. So if we are using a moist reagent, then the ammonia gas will just dissolve. So it is very, very important to note that the reagent must be dried. So, and you can also see here that the flask containing the mixture, it is set in a slanting position. It is set in a slanting position to prevent water which is condensed on the cooler parts of the apparatus from running back into the flask and causing it to crack. So that is why we have the orientation of this flask must be slanted downward. It's very, very important to note this one because sometimes you will be given the diagram in an exam, and then where you are required now to identify the mistake, you check the slanting position, that the flask must be in a slanting position. For example, in this question, you will be required here now. We can see we have a mixture of ammonia, ammonium chloride, and calcium hydroxide. This is a mixture. And then now the flask is not slanting downward, it is just upward. So this is a mistake because you have been asked here that identify two mistakes in the setup and give a reason for each mistake. So you need to check at the orientation of the apparatus. When you are told to identify the mistake, of course you can look of the drying agent. A drying agent, it must be wrong drying agent. You can also look at the reagents used. If it is moist, then that is a mistake. The reagent for the preparation of the ammonia gas must be dry. So when you are asked to identify the mistake, so those are some of the things that you are supposed to look at. And again now the gas, the it after being heated, we have a gas which is being collected and passed through the drying tower. The drying tower, we have calcium oxide. Calcium oxide, it is the most suitable drying agent for ammonia gas, because if you use other drying agents like likes of concentrated sulfuric acid cannot be used as the ammonia gas will dissolve to form ammonium sulfate. So as you can see here, conc sulfuric acid cannot be used as a drying to dry the gas. Calcium chloride cannot be used to dry the gas, because if the calcium chloride can be used to dry the gas, calcium chloride forms a complex compound with ammonia. So in this case here, we have a complex compound with ammonia. So the best drying agent, the most suitable drying agent for the ammonia gas is calcium oxide. And of course now, as you can see from here, that the gas is collected by the upward. Once the gas has been dried, it must have to be collected by the upward delivery, because the gas is less dense than air. Now, there are some important things you need to note. The round bottomed flask should be slanting downward, and that one from left to right. It must be slanting downward from left to right. This is to prevent the water formed on the cooler parts from condensing and flowing back, which may crack the flask. A very important point to note. A moist reactant should not be used. A moist reactant should not be used, as this will dissolve the ammonia gas produced. So we cannot be using the moist calcium chloride. We cannot use the moist calcium hydroxide. They must be dry, because if they are being used as a, when they are moist, the gas produced will dissolve the ammonia. The moist reactant should not be used, as this will dissolve the ammonia gas produced. And again, once the gas has been dried, very, very important to note, it must be corrected by the upward delivery, as it is less dense than air. So the methods of the gas collection must be collected by the upward delivery as shown on this diagram, because the gas is less dense than air. Then the main drying agent, as I have said here, it must be dried passing through calcium hydroxide. Very, very important. But you cannot use the concentrated sulfuric acid, or you cannot use anhydrous calcium chloride. With concentrated sulfuric acid, it will form ammonium sulfate fertilizer, and therefore there is no gas that can be collected. If you use anhydrous calcium chloride, it will form a complex compound, and therefore no ammonia gas will be produced. So the gas must be dried using the most suitable drying agent, that is calcium oxide, and not the concentrated sulfuric acid or anhydrous calcium chloride. And this is because they react with the concentrated sulfuric acid and the calcium hydroxide. So and if they react, and therefore we are not going to have the gas. We are not going to have the gas being collected. Now we proceed. Now, how do you test for the ammonia gas produced? How do you test that the gas produced is ammonia? Testing for ammonia gas, sometimes you will be asked to describe how the ammonia gas is being tested. Describe an experiment, tell an examiner, give the procedure, give the apparatus used to describe how the ammonia gas is being produced. Ammonia gas, if you are being asked to describe how ammonia gas is being tested, you dip a glass rod into a concentrated hydrochloric acid solution and bring it into a mount of a gas jar full of ammonia gas. It will form a white fumes. So if you dip a glass rod, you can dip a glass rod into a, you dip a glass rod into amount of a gas chamber full of ammonia gas, it forms a white fumes, and that is you have described how the gas is produced. So when asked describe how the gas is being produced, simple, that is what you are supposed to write. But if you are being asked now, state how the gas is being tested. How the gas is being tested, it reacts with hydrogen chloride gas, forming a white fumes of ammonium chloride, and that is now will confirm the test for ammonia gas. It's just simply say it reacts with hydrogen chloride gas, and it forms a white fumes of ammonium chloride. Now, what are now the physical properties of ammonia? Now, before we come to the physical properties of ammonia, we are said that there is ammonium chloride is being reacted with calcium hydroxide. Why is calcium hydroxide being used? Calcium hydroxide is commonly used because it is readily available, it is cheap, and it does not corrode the glass. Simple. Ammonium chloride is the salt which is commonly used in this case with calcium hydroxide. So if you will be asked now, give the reasons why a calcium hydroxide is commonly used. There are only three reasons. One, it is readily available. It is cheap. It does not corrode the glass. Simple. Physical properties of ammonia: it is a colorless gas. It has a pungent smell. It is less dense than air, and that is why you can see from the diagram why that is the reason why it is collected by the upward delivery, because it is less dense than air. Once the gas has been dried with calcium hydroxide, it now becomes less dense than air, and that is why the gas is collected by upward delivery. The gas is highly soluble in water, and hence now a solution of ammonia is prepared using an inverted funnel to prevent the sucking back. So sometime now you will be asked again to draw a well-labeled diagram for the preparation of ammonium solution. Draw a well-labeled diagram for the preparation of ammonium solution. So for the preparation of ammonium solution, it must have been prepared using an inverted funnel. As you can see, we said that the orientation of the flask must be slanting downwards, that's from left to right, to prevent the sucking back of water, which may crash the flask. And then we have a dry calcium chloride and ammonium chloride. The reagent must be dry. The reagent must be dry. Very, very important to note. Now you can see a water vapor which can condense here. If the flask could not be slanting downwards, this water, once being condensed here, it could flow back to the flask, and because there is a heat, it may cause the flask to crack, and therefore that is why it is being directed, the orientation, it is being slanting downward like that. We have the conical flask, there is an inverted funnel here. The inverted funnel here, it is used for two reasons. One, to increase the surface area for the ammonia gas to dissolve, to increase the surface area for the dissolution of ammonia, and to prevent the sucking back to the hot flask. So the purpose of the inverted funnel is to provide a large surface area for the dissolution of ammonia and to prevent the sucking back of water to the hot flask. So those are the main two reasons why we are using the inverted funnel. It is also used, the inverted funnel is also used to prepare other very soluble gases. So this funnel can also be used to prepare gases like likes of hydrogen chloride. We have sulfur oxide gas and nitrogen oxide gas. Kindly follow my channel, click click the notification bell. You get notified once I upload a new video.